everyone, today I have come to an imaging facility within the Ashoka University, and this imaging facility has been collaboratively established by Ashoka and ZEISS, yes, and this is first of its kind, as you can see, revealing life across scales down to molecular details. So, from macro to nanoscale imaging, and this facility has all the modalities which you can think of when you are dealing with light microscopy. So, this is the entire portfolio, and out of this entire portfolio which ZEISS microscopes has, in this facility we will be able to see some of the state of art instruments, starting with lattice light sheet, the wide field automation which is the Cell Discoverer 7, the LSM 980, and along with this you also have a multi-photon attachment, and last but not the least, the super resolution which is the ELIRA 7. So, I am very much excited to see what all instruments are there. Please follow me. So, I have entered the facility. As you can see, they are all different instruments positioned into different compartments or segments, and the light microscope setup or the environment requires a dark room, and keeping that in mind, you have all these black curtains to curtail or to cut off excess light during imaging. So, we have multiple systems as we have discussed outside, and as we enter we get to see a small intro for all the systems. The LSM 980, multi-photon, you have the Cell Discoverer 7, the lattice light sheet, and the ELIRA 7. This is the super resolution microscope. So, we will start with Cell Discoverer 7, and the system is this one. So, this is the Cell Discoverer 7. I already had made one more video, previous video for the Cell Discoverer 7, which was in the Sathi facility, IIT Sonipat. That campus is very much next to this campus, and I am standing right now at Ashoka University. So, this is Cell Discoverer 7, but it also has LSM 900, and not to forget the super resolution detector module, which is the Eriscan. So, as you can see, the Eriscan 2 is also available in this configuration, making it a wide field system. Along with it, you are capable to do a confocal imaging, and if you want to improve on your resolution from 240 to 50 nanometers to less than even 100 nanometers, then this Eriscan will take you less than 100 nanometer resolution. So, this system is basically a workhorse where high throughput imaging, you have lot of data generation requirement, you come to this system, it works in a more or less in an automatic function. You do not have a typical eyepiece to visualize this, but you do not need to. So, if you see the previous video, I have given a very detailed description of the CD7, but here in this case it is more or less the same configuration, only with addition with the Eriscan 2, where your resolution will be going to 100 nanometers or beyond that. So, now I will take you to another system. This is, yes, this is LSM 980 in a upright configuration. This microscope frame is Axio Examiner Z1, and in the upright configuration you get an advantage to do intravital imaging. You can take your sample which has a large depth, and from the top with the help of these objectives, and some of them are even water dipping objectives for deep tissue imaging, this system has been designed, and you can see the large stage where your samples which has a larger volume can also be positioned very easily. They are fully motorized, and you can do 3-color confocal imaging at the same time with the help of this LSM 980 module. So, this is basically the scan head of LSM 980, and confocal system in an upright microscope frame is always there. In addition to that, you also have multi-photon lasers from spectra physics. So this multiphoton laser from 690 nanometer to 1040 nanometer, it is a tunable laser line, and this tunable laser line will also give you an advantage to do multiphoton imaging. And for that we have also a dedicated multiphoton detector, that is the big 2 detector. So this entire method works on non-D-scan technology, where you need to have a very deep inside imaging, where your sample volume is literally very thick, near to 1 mm. Those type of samples you can easily do with the multiphoton, where you can illuminate a specific Z within the sample volume and collect signal from a particular plane. And there is no concept of having a out of focus or haze informations, because the tunable lasers are designed in that way, where without scattering it goes deep inside the sample and comes back with informations. So as you can see, have a look at the system. This is upright, so the scan head is on top. This is very unusual sort of configurations. It's not very common, but still, as the requirement for intravital imaging is an upright platform, you can see the scan head on top, and then the laser modules and everything on the electronics are at the bottom, and you can see a anti-vibration table from Newport, which actually is on a floated pillars. So the air and the pressure is floated. What happens is, whenever we have a vibration from top, there is an equal and opposite vibration comes and it nullifies. So this is active anti-vibration table, which you can see here. Now we have come to the super resolution microscope, and that is the ELIRA 7. So this is the ELIRA 7, and again it is a inverted microscope frame with the Axio observer from ZEISS, and this black box is actually helping you to maintain a small dark room when your sample is positioned inside. So when the lights are on, then also you can do this imaging, and as they are all, you have access to internal parts, how you can position your sample. This is a Hall censored black box. So where if any of this is open, the laser will not start firing and the imaging will not happen. So once you close the entire setup, then this is a closed system where your imaging can happen. Now this is a camera based system. So you can see there are two cameras from PCOH. They are SCMOS cameras, PCOH 1 camera 1 and camera 2, and they are separated with a secondary beam splitter at this point into two separate cameras, where we can do 2 color to 4 color imaging in this system. The laser module is this big box, which is the laser module. It has basic 4 lasers, blue, green, red, far red. Imaging can be done, and this is the ELIRA box, which is integrated at the back port of the microscope, and this brings the grid or the lattice grid in front of the light source, and this pattern is generated. This pattern illumination falls onto your sample, and then we actually generate higher cutoff frequency, which helps us to resolve our sample to 60 nanometer, 60 nanometers, and there are no sample preparation requirement. The sample preparation which you have been doing it for your confocal samples with a normal fluorophores, the choice of your fluorophores remains the same as far as when imaging in this system is concerned. In case if you want to do long term live cell imaging, then you also have the incubation system. You see the CO2 control and the temperature module, the heating unit. This entire black box temperature will be maintained by that heating unit, and the CO2 temperature module in the sample holder, as well as the humidification of the premix air will also be taken care of, maintaining a very cordial environment where the live cell imaging can happen for a very long time. So this is suitable for your live cell setup as well as for fixed cells where you are looking for resolution. Resolution should be your criteria, but as this is a camera based system, you will not compromise onto the speed as well. So your temporal as well as spatial resolution both are equally high, and you can expect a resolution of 60 nanometer in the X and Y, and also in terms of speed, this can go maximum to 255 frames per second. Yes, so that is quite a fast, and it is very suitable for live cell imaging as well. So now I have come to the last system, and this is one of the first system installed in India, and as you can see here, this is the lattice light sheet 7. The lattice light sheet 7, and in a very compact design, it is meant for volume imaging, for even for your fixed lights as well as for your samples which are in Petri plates, means for live cell setup as well as for fixed cells. This is a very suitable system where volume imaging is the primary concern, and with the high volume imaging we require a very high sensitive detector which is there in the form of a camera. The camera you can see is Orca Fusion camera from Hamamatsu has been given, which has a very high quantum efficiency, which enables to translate low light signal into beautiful images. So for samples which are in Petri plates, for samples which are fixed, for samples where you want to do dynamics, long term imaging, and you are concerned about volume imaging at a faster rate without compromising onto the signal to noise ratio, then this is your system. I have already made a detailed video of the introduction of this system, and you can always go and have a look at it.